All right, today we're diving into a piece of hardware that's promising to put the horsepower of an entire data center right on your desk. And yeah, it could completely change the game for anyone building with AI. Let's get into it.
In the world of AI, this isn't just some fancy quote. It's the whole playbook. Every single major breakthrough we've seen, from deep learning to large language models, has been a massive disruption. But what happens when the innovators themselves get stuck?
And that's the exact question so many developers and creators are facing right now. They've got these incredible, world-changing ideas, but they're stuck in a queue, just waiting for access to the tools they need to bring them to life.
This waiting game has a name. We're calling it the AI innovation bottleneck. It's a super frustrating reality where brilliant ideas aren't held back by a lack of imagination, but by a simple lack of access. I mean, this slide just lays it out perfectly. For years, if you wanted to do serious AI development, you were tied to the cloud. And that meant dealing with high costs, getting budget approvals, and just waiting for resources to become available. It's kind of like being a painter who has to book studio time a week in advance just to try out a new brushstroke. And as you know, that's just not how creativity works.
So how do we smash through that bottleneck? Well, that's where a whole new category of machine enters the picture, with the wild goal of putting a supercomputer right on your desk.
Okay, so meet the Nvidia DGX Spark. It's being called a personal AI supercomputer, and for good reason. It's this self-contained, compact workstation designed to give developers all the power they need, right where they are, with zero wait time. And when we say power, we really mean it. This machine is pushing out 1 petaflop of AI performance. That's a quadrillion, with a Q, calculations per second. Just wow. And this is the part that's truly mind-bending. All of that insane number-crunching power is packed into a box that literally fits on your desk. It's a total shift from needing a whole server room to just needing a little bit of desk space. So how on earth does it do that? Well, it's built on the new Grace Blackwell architecture, but the absolute secret sauce here is its 128 gigabytes of unified memory. This lets the CPU and GPU share one giant pool of memory, completely sidestepping the VRAM limits that just cripple even super high-end PCs when they try to run massive AI models. We're talking models with up to 200 billion parameters.
Here's a fantastic way to think about it. For decades, musicians had to book crazy expensive studios to get that professional sound. Then, technology brought the studio right into their homes. The DGX Spark is aiming to do the exact same thing, but for creating AI. It's putting the pro-grade tools directly into the hands of the creators.
Okay, so you've got all this power. What do you actually do with it? Let's start with one of the biggest fields in AI right now, large language models.
So, conceptually, getting your own private ChatGPT-like interface running is a layered process. First, you start up a model engine, something like a llama. Then, you load the AI's brain, a really powerful open-source model. And finally, you connect a user-friendly chat interface like WebUI. And boom, just like that, you've got your own private AI sandbox ready to go.
And the result is just awesome. You have a completely private, offline, self-hosted chat AI. You can experiment with it, fine-tune it on your own data, and prototype new applications without ever sending a single piece of information to the cloud or waiting in line. And the scale here is really what matters. A 20 billion parameter model, which would be a huge struggle for most high-end gaming PCs, it just runs comfortably on the Spark. But it can even handle enormous 120 billion parameter models. That's the kind of industrial strength AI that, until very recently, was only possible for the giant cloud providers.
But it's not all just about language, right? Let's switch gears and see how this same power can be used in the creative world of AI image generation.
Setting up a local AI art studio follows a pretty similar logic. You'd launch a creative workshop like ComfyUI, which is known for its insane flexibility. Then you load up a powerful image model, say Stable Diffusion. From there, you get to build these custom visual workflows using a node-based system to control every single aspect of the creation process.
What you get is basically a creator's dream, a sandbox where you can experiment with incredibly complex visual ideas, chain different models and effects together, and iterate on your art with almost instant feedback.
And yup, you guessed it, that 128 gigs of unified memory is the hero of the story once again. It's what lets you load multiple big models at the same time, or generate images at extremely high resolutions. Tasks that would just drain the VRAM on a normal graphics card and bring your creative flow to a grinding halt.
So, when you put this all together,
What's the bigger picture? Well, it's really about changing the whole rhythm of innovation itself.
What this really means is that having a personal AI supercomputer fundamentally changes how you work. You can experiment way faster because there's no queue. You can prototype bigger, more ambitious ideas without worrying about hardware limits. You can iterate in a totally safe local environment. You actually get to own your entire AI workflow, from idea to execution.
And this slide just captures that sentiment perfectly. It's not about having one big disruptive idea. It's about creating an environment where you can try things, test them, refine them, and do it all over again, every single day. It makes innovation a daily practice, not a once-in-a-blue-moon event.
And that leaves us with one final, and I think really exciting, question. When the bottlenecks are gone and the power of a supercomputer is just sitting there, what kind of future would you decide to build?